Good morning, everybody. I'm going to talk about African groups today. So migration within Africa is not very well understood. And in the past, it has been based on the 4 language groups, which are illustrated here. The yellow group is the largest group, and there is a feeling that there was migration from the center of Africa to the west and then to the east and south. In more recent times, there is the beginning of a lot of DNA work looking at admixture to try and work out the patterns of migration within Africa. So it's a very exciting time. The question we've asked is, can the timing of tooth formation tell us anything about migration patterns? So we want to quantify differences in tooth formation between several African groups. So my Millennium Project, on the 1st of January 2000, I thought, what's the biggest project in my particular field? And it was differences in world groups in tooth formation timing. It's now 16 years later, and the title has changed slightly. It's now Similarities in Tooth Formation Timing Around the World. But this is part of an ongoing project. What do we know about reference samples in tooth formation from Africa? Not very much. I've done some work from South Africa. I was born in South Africa, on third molars, so those are the wisdom teeth. I looked at the timing of third molars in South Africa compared to the reference group in London, where I live. And I've been extremely fortunate to have a fantastic colleague, Fadil, who is in Sudan, and he did his PhD on 2 ethnic groups in Sudan, in Khartoum, the northern group of Arabic origin, and the western group who have migrated from the west of the country. And he found, surprisingly, similarities. We didn't expect that. And so that was published earlier this year. So I'm aware that you know nothing about teeth and tooth development. So teeth develop, they start before birth, and they carry on until 22, 23. It's complex. Everybody has 20 deciduous teeth and then 36 permanent teeth. And so I'm showing one side of the jaw. And one of my other students has done a lovely atlas, which is available online in 20 languages, so please look it up if you want to ever use it for teaching. But this illustrates the deciduous teeth in grey and in green the permanent teeth at about the age of 4. So there's a sequence of development from before birth up to late teens, early 20s. This is a little bit later, where some of the deciduous teeth have been exfoliated and been lost, and the permanent teeth. So this is about 6. At this age, almost all the teeth except the third molars have begun. A little bit later, the last deciduous teeth are beginning to resorb, permanent teeth growing a little bit more. And at around about 12, all the teeth are developing at the ends on the left-hand side of the third molars. So this is the sequence of events. And how we quantify this is quite difficult. We have to think about the sequence. We can break it down into units of each tooth, and we can divide the tooth into tooth stages, crown and root stages. So these are discrete events of a continuous process. And I'm not going to bore you with lots and lots of graphs of all the teeth. I'm going to just talk about molars. That's lucky because molars cover the whole period. And so the oldest part of our bodies is the first permanent molar. That's the timing when it starts at birth. So if you've got your first permanent molar, that's as old as you are. The second molar starts at about 3. Finishes about 12, the third molar starts at about 9-ish. So that covers the whole growth period. So our sample and methods, quite a few children from South Africa. I've been lucky enough to go to Lagos and to Senegal collecting data. I'm a dentist, so I go to dental practices or dental schools and look at archived dental radiographs shown on the right, and that red circle shows the first molar, the second molar, and the position of where the third molar will develop. The reference sample is UK, white children, and a recent migration, second generation Bangladeshis. So the hospital I work at is Barts in London, in the east end of London. It's in Tower Hamlets, which is a very poor region with a lot of immigration. We have a lot of dental disease. So our patients come to us. The children sometimes have to have 10 teeth out under general anesthetic. It's good for us because our students get good experience, and it's wonderful for me because I have a vast collection of x-rays. We have fantastic radiographers. We can take radiographs of 2-year-olds. Most regions in the world don't take radiographs under the age of 6, even in UK. So for the South Africans and the West Africans, we have very few young children. So this is a problem. But when Fadil came saying he wanted to do a project, I said grandly, we need a random sample. And he came back with a random sample from 3 to 22. So it is the only random sample of dental reference data that has been published. So how we do this is we divide the tooth stages. We look at all the radiographs, select the stage, and then look at the age range of that stage and work out the mean age, probe it, regression. And so this is the traditional way of doing things, looking at tooth stages. Another way of looking at it is to look at a timeline and look at relative tooth formation. So I've got 2 radiographs there. The one on the left is when the first molar, the root, is almost complete. It's the penultimate tooth stage. The apex is half closed. That's around about the age of 8. So I've selected the radiographs at that stage and looked at the third molar. Another timeline is when the second molar is almost complete. That's around about 14. So we are comparing findings from the 2 West African groups, the South Africans, and then the 2 Eastern African groups. And this is just one example of the last tooth to develop, the third molar, initiation of the third molar. I've grouped the 2 Western groups together, and you can see that the mean age, this is the mean age plus the error of mean, the Western group is considerably earlier. The South African group is also considerably earlier. The 2 Sudanese groups are very similar. Unfortunately, we can't get data for the initiation of any other tooth because of the age range. So that does present a problem. I showed you the mean groups, the mean ages. This is for individual tooth variation. There is a large standard deviation of all tooth stages. And so the youngest child we have with the third molar developing is 4, and the oldest is about 13 or 14. So that's the age range. That's why you can't use this tooth to estimate age accurately. So the red is the West African groups who are earlier. Another way of looking at it is to look at relative tooth formation, looking at those 2 timelines. And the middle graph shows that the Western and Southern groups, including the Western group in Sudan, have a higher proportion of third molars developing. So they seem to be ahead. But if we look at the other timeline, this pattern isn't exactly the same. The Western and Southern African groups are earlier, but the Western Sudanese are identical to the Northern Sudanese. So it's complex. So our main finding is that all the groups, including the groups of rest of the world, which I'm not talking about, seem to show that we have a biological clock. And we can relate that to the dentition and to the tooth. So that if you have a fast dental clock, you're going to start your teeth early and they're going to finish early and you're going to reach maturity early. But there are children in all these groups who also have a late clock. They start late and they finish late, which has not been documented before. Another way of looking at this, these blue bars show the crown formation. So crowns are very stable. Enamel is much less plastic in its developmental timing and shape. So the first molar is the bottom blue bar, the second molar is the next one, the third molar, and this whole sequence can be compressed in time with a fast clock, or it can be stretched out in time. And these children look identical. We can't differentiate from the outside whether they have a fast or a slow clock. If you're measuring stature, it will be noticeable because the child will be shorter or taller for their age. But with tooth development, it's not been done. That doesn't mean that it isn't there, we just need to look for it. So our conclusions are that tooth formation can't really tell us much about the migration patterns in Africa because it's too complex at the moment, except for the early forming third molar in the west and south groups. And further study may throw light on the topic by looking at the tooth shape, the surface of the tooth, as well as from radiographs the pulp and the root shape. Some groups have extra teeth, some groups have missing teeth, and the growth of the jaws and face are also important. So the message is that teeth are really stable and don't seem to change. Thank you for listening.